Hello students, in this video we will discuss some of the most important examples on stability of carbocation. For the stability of carbocation, you firstly have to write all the effects in this first compound. Here I am having carbocation which is attached to a benzene ring. So we are going to say that here it will have resonance from 3 pi bonds. Okay, then this carbocation is attached to carbons as well. So you are going to have hyperconjugation also. So how many alpha hydrogen it has? 2 and 2. So total 4 alpha hydrogen. So I'm going to write like this, that 3 pi is stabilizing resonance and then 4 alpha hydrogens are stabilizing it. Okay, then in the second one, again you have a phenyl. So 3 pi. But now can you see this is a double bond which is adjacent to the carbocation. So it can also show a resonance. So over here, if I draw the resonating structure, it will exist like this. You have a phenyl ring here and double bond and now a carbocation at this position. So we will say one extra pi bond resonance is there. How many alpha hydrogens it has? 1, 2 from this side, and then when it is having conjugation with the double bond, so we are having, this is also alpha, so 2 alpha hydrogen from this side. So total 4 alpha hydrogen. So whenever this type of a question is there, that you can have resonance and then you can add more stabilizing factors. So you have to make it like that. So 3 pi, 1 pi, so total 4 pi stabilizing and 4 alpha hydrogen. Now see in this case, third case, we have a phenyl which is attached to a carbocation and then a double bond. So similarly here 4 pi will stabilize it. Now we are going to say, when I will make it the resonating structure, so we are going to have oxygen here. Now positive charge will be present here, double bond, and this is your phenyl ring. So what is different here in this condition? You have a lone pair species which can have plus m effect. So extra thing, that is the most stabilizing factor, is the plus m. Moreover, there are alpha hydrogen also, and similarly here there are 2 alpha hydrogen. Okay, then in the last structure I have aromaticity, because how many pi bonds? I have 3, so 6 pi electron, and that is why it is aromatic. So we are going to say that firstly the most stable is the third one because it is having plus m effect. So 3 is the most stable one. Then you are going to say aromaticity. So fourth one, because I have given you the order that how you are going to see the stabilization. Firstly you need to compare mesomeric effect, then you need to see aromaticity, then you are going to see resonance, hyperconjugation, and at last inductive effect. So this is mesomeric effect, then aromaticity. Then I will say in the second and first case both are having resonance and hyperconjugation. But here we have 3 pi resonance and here we have 4 pi resonance, and resonance win over hyperconjugation. So that is why we are going to say 2 and 1. This is the correct order for the stability of carbocation. I hope this is clear. Okay. Then in the second case also similarly you need to see, here I have directly attached nitrogen which is attached to a carbocation. So directly you will write plus m. That's the most stabilizing factor. Then here we have oxygen, so oxygen will donate. Similarly we have plus m effect here. Now here carbocation is not directly attached to a lone pair species, it is away. So you are going to have just alpha hydrogens, that is hyperconjugation, so 4 alpha hydrogen. And in this case we have benzene ring, 3 benzene rings, so resonance, and resonance is basically 9 pi bonds total. So total 9 pi bonds. Okay, so here also you can easily write the order. Firstly we will see first and second is having the maximum plus m effect, that is stabilizing effect. And which has more plus m effect? We know that nitrogen has more plus m effect. That is why it is first, then it is second, then pi bond and hyperconjugation. So obviously resonance will win over hyperconjugation. So fourth and then third. This is the correct order of the second one, that this is the stabilizing factor. Then next, in this case, what is different over here? Now benzene ring is attached. So basically now you have to see that what are the different groups attached, because all are having same carbocation. So in this NO2 is different, in this OCO is different, COCH3 and CH3. So I will write the effects of these one. So over here, I will write the effects for each of the substituents attached. I will say NO2 minus M effect. Now, oxygen over here is directly attached. It will have the donating effect. So it is plus M. COCH3, it will not have a lone pair. So COCH3 will act as a plus M. Yeah, COCH3 will act as electron withdrawing group, so it will have minus M, and CH3 hyperconjugation 3 alpha hydrogen. So we are going to say stabilizing factor is plus M and 3 alpha hydrogen because electron donating group is required. So we will say second is the best, then it is the fourth, then NO2 and COCH3 both are having minus M. I want my stabilizing factor. So that minus M, which is electron withdrawing but less electron withdrawing. So here I will say COCH3 is better than NO2. So this is the correct order for stabilizing. So these are the order for the stabilization of carbocation and they are important. I hope you understood this concept. We will meet in the next video. Thank you everyone.